Once more, let's see the definition. A reaction that gives out heat to the surrounding is said to be an exothermic reaction by definition. Okay, let's have a good look at now a few examples. Simple day-to-day life example is adding basic oxide to water, calcium oxide with water. It releases heat. That's why it is mentioned in certain red color bin, and it releases heat to the outside. That simple example is release heat and just system gain some temperature. You might be really wondering why is that? Actually, why? Because new bond making, formation of new bonds, and it's common in day-to-day life even. Now think about certain, say, like you have certain relationship. When you are in the process of making a relationship, you have to put certain more energy. A relationship with a life partner or friends or parents or anything, you have to put your own energy. You release energy to sustain the bond. That's something you can get from the day-to-day life. Combination, chemical single displacement reaction, double displacement reaction, all of these types of new bond making reactions are always release energy to form the new bond. That's the nature. That's also same for the human nature as well. Now get some example. Simply any type of reaction that produce flame are supposed to be exothermic reactions. That anything that catch fire, likes of hydrogen catch fire, methane catch fire, gas catch fire, petrol catch fire, anything. So release temperature because of exothermic, and the acid-base neutralization is a good example for just releasing heat. HCl and NaOH is a good example for releasing heat energy. The very next task is to analyze this in the graphical analysis. According to the graphical analysis, potential energy versus the progress of the reaction at the reactants at the beginning has higher energy after the activation energy, and the products has a very low energy. We can simply represent this in a certain simple diagram. Reactants have a high energy and the low energy for the products, and the energy difference you can see that it is releasing because something like you jump from upstairs to down. Very next type is endothermic reaction. The reaction type heat absorb heat energy from the surrounding state to be exothermic. The gaining heat, absorbing heat, according to that acid, absorb the heat that's getting cooler. Because the heat is absorbed by the elements, so the system get really cold. That's what happened. It's very simply you can just say that any reaction that absorb heat from the surrounding is said to be endothermic, which gains energy internally, and the system gets really cold after result of it. You might wondering why is that? Because it's also because of breaking the existing bonds. So it's also common in the human nature as well. If you are in a really good relationship with someone, your friends, teachers, or anybody, so others feeling jealous and try to break your bond. So it's putting all the energy on you to break the bonds. Any bond breaking is endothermic. Decomposition reaction, copper carbonate and forms due to heat, copper oxide and carbon dioxide, potassium nitrate, and it forms potassium nitrate and oxygen. And according to bond chart, so reactants have lower energy rather than of the products through the activation path. So the energy difference is a positive value for endothermic reactions because the system is getting cold, because the particles absorb high energy from the surrounding to get high energy status as the products. That's it. As we have done it, and now it's time to find out the measurements of the energy. How to measure the stuff? Measuring energy changes the change because you can measure using the following equation. Q equals to mc theta. Each term Q is the heat energy, m is the mass, and whereas the C is the specific heat capacity, delta T is the temperature change. The mass is given in grams, and the mass have to be used in some equation. 1 cm3 is equals to 1 gram because the density is equals to mass over the volume. When the volume becomes 1 cm3, this automatically becomes density is equals to the mass. So according to that one, so directly density is the mass. So from that one you can get mass is directly equals to the volume. For any example, for a certain aqueous solution, the mass is directly equals to the volume of the stuff. Then you can find the mass, and the specific heat capacity is mostly given by joules per gram per Celsius or joules per gram per Kelvin. So no need to convert any units. Let's have a good look at certain example. An aqueous solution solution that has 30 cm3 and the temperature is 25 cm3 and it's really cold. And the next when we provide heat and the heat raised to 45 degree and the volume remains unchanged like 30 degree and it's now kind of hot. Now you have to find out the amount of heat transfer using Q equals to mc theta. So you have to analyze the mass. Mass is the 30 grams because of volume is equals to 30 cm3 and the C is equals to 4.2 Gc minus 1 and the temperature is 45 minus 25, it's 20 degrees Celsius. Applying to the equation, Q is equals to mc theta, Q is 30 and 4.2 and by 20, and you can cut grams per gram and Celsius per Celsius to Celsius. Final thing remaining is the joule. So the amount of energy is Q 2520 joule. That's really simple to apply. This is a very simple demonstration of how to calculate, and I have no intention to lengthen the video furthermore, and I'm just about to make a very complicated an example with examples video for enthalpy changes and for calculations according to exam structure. Wait for that, and God bless you and have a nice day, and subscribe to my channel and stay blessed and wait for my new